In this video, we are going to discuss section 4.4, percents and compounding. And in particular, this video will address only the first of our objectives, using percents in the context of multiplication to compare quantities. Just 5 quick examples to go through, and then we'll finish up. First one, compare 12 to 15 using percents. And since that's fairly vague, what we'd like you to do is to create a percent proportion or a percent equation and be able to say something like 12 is 50% of 15. A statement like that. Obviously, we know 12 is not 50% of 15, but we want it to have that kind of a structure. Thus, how do you set that up? Okay. Generally speaking, when you work with percents, you will use a proportion, a fraction, or an equation, which generally is decimals. One way to look at this is to say we could compare 12 out of 15, and that will be equal to some percent, and we know percents are based out of 100. So one way we can do it is to set up this percent proportion and then solve from there. To solve this proportion, or to solve any proportion, we know one technique is to cross multiply. 15 times p is 15p, and 12 times 100, 1200, and we've created an equivalent expression with an equivalent equation which we can solve. Just divide by 15. So now, what is 1,200 divided by 15? Recognizing that most people will use a calculator to save some time. So it's 80, and so we've created an answer. This still does not accomplish what we were asked to do. We have not compared them yet. To compare it, we would just write it up and say, "12 is 80% of 15. Let's do something similar. Compare 15 to 12. So how is it different? We flipped the numbers around, and so we're not thinking of the proportion 12 over 15. Now we're thinking of the proportion 15 over 12. Cross multiply, we'd have 12p equals 1,500. And what is 1,500 divided by 12? And so 125, to make that comparison, we could then say 15 is 125% of 12. Our third one, m is 45% of n. Write it as an equation. Well, we know that this is something that we could write with the percent proportion. And there are several different correct ways to do this kind of a problem. I'm going to show you 3 different ways of looking at it. A common mnemonic that teachers use for the percent proportion is over of equals percent over 100. And they're using these just to provide you with clue words or keywords to help you identify where things fit into the percent proportion. When reading it, we can see m is 45% of n. And by choosing these keywords, is, of, and percent, they help us identify where the things go in the percent proportion. M is so m goes in the is position. 45%, of course, goes in the 45 position of n, so we can then build a proportion, and we do have n equation. We know that we'd be able to cross multiply this piece and say 45n equals 100m. And just to further elaborate on this, if we were to divide both sides by 100, that would be, I have my decimal in the incorrect location there. 45 divided by 100 is 0.45n equals m. And so here's one correct way to set this up. It is not the only correct way. You likely had teachers that showed you this could also be done reading it just one word at a time. M, so we'll write down M, is means equals 45% of, which means multiplication, n. And so we can create an equation which has the percent symbol in it. Unfortunately, when we work with percents, we virtually never, well, we can't do operations in the percent symbol. We can have fractions, we can have decimals, either one of those are fine. Well, if we choose to write it as a decimal, 45% is 0.45. And you can note that that's the exact same thing that we have down in the red. It just gives us a different way of building it. Many people like working with proportions because it has just a quick, guaranteed, you know how long it's going to be. After you set up the problem, it's just cross multiply and divide to solve. So many people like proportions more than they like working with decimals. If you have a solid understanding, though, of the relationships with decimals, generally speaking, as we can see with this one, the pieces in the blue tend to be a whole lot quicker and shorter and just basically faster and less writing. It generally requires larger understanding, more in-depth understanding, but with that understanding makes the problem easier. Consider this example 4. 25% of as a function. After that, we'll write it as a verbal rule. Well, since we're writing it in function notation, we know we're going to have something of the format f of x. So what's going on with 25% of? Think back to the last example. What operation does this indicate? Percent of, and in particular this word of, that's one of the key words for multiplication. When we see 25% of, it's telling us that we would have 25%, which I'm writing as a decimal, 0.25, and it's 0.25 of the argument. Thus, we can see the similar structure to what we had before. 45% of n we had written as 0.45n. Please note the similar structure. 45% of was just a way of saying multiply by 0.45. And for our function notation, this 25% of is telling us 0.25 multiplied by something. Since we're looking at a function, it'll be 25%, 0.25 times the argument, our input. What is this as a verbal rule? What did I just say? What operation did we do? What's it? 25% of is simply another way of saying multiply by 0.25, which we know is the same thing as multiplying by a quarter, which is the same thing as dividing by 4. And the last example for this particular video. It's also the toughest one. Compare the area of a circle inscribed in a square to the area of the square. And one thing to keep in mind, when we did this compare earlier, it was something like 12 is 80% of 15. Our goal is to write up a statement like that. The area of a circle is some kind of percent of the area for this square. We're trying to figure that out. Well, how can we do that then? If we're trying to compare two areas, what makes sense as a strategy? Well, how do you get the area of a circle? How do you get the area of a square? The area of a circle, we know, is pi times radius squared. So we'll take here and say, there's our radius. And we also need to somehow compare that to the area of a square. Please notice that's our radius as well. And so the entire length, radius plus radius, would be 2 times the radius. Thus, when we have 2 radius for the side and 2 radius for the side, what is the area? 2r times 2r, which is 4r squared. And so we're trying to compare these two things. Please keep in mind what this last example did for us. 25% of, we were able to write as percent times argument. There is a similar structure here. We can set this up as percent to get argument. In particular, if we wanted to divide this out, so we would have the area of the circle compared to the area of a square. Do you see that the structure here for area of circle compared to area of square is the same type of thing that we started with, 12 and 15? We started by creating the fraction 12 over 15 to compare them. Well, to compare area of circle and area of square, we have likewise created a fraction. So what percent is that out of 100? And so we can do this with the percent proportion if we wanted to, Or it might be easier just to do decimals. As we saw back here, if we use decimals instead of the proportion, there's a lot less writing and a lot less work. I don't know about you, but I'm a lazy person, and if I can do less writing and less work and get the same correct answer, that's the way I want to use it. For this particular problem, I would rather take our fraction here and write it as a decimal. What happens with r squared over r squared? R squared divided by r squared cancels each other out. And so our percent is pi over 4. But it's just not written in decimal format. Let's grab our calculator. What's pi divided by 4? Written as a decimal. Using the pi button on our calculators, not 3.14, dividing that out, we've got 0.785, rounding it to 3 significant digits. So what percent is that? Okay, 78.5%. So we can finally describe this and say, if we're going to write it as like a full sentence, the area of a circle is 78.5% of the area of a square. When the circle is inscribed in the square. So here's just one way that we could write up a sentence explaining what was going on. Looking forward to the next video. Our second objective is using percents to keep track of changes. In the next video, we will look at problems like here. Wrench's sales are down 22% from last year. We can use percents to keep track of changes over time. And the next examples in our video all have to deal with the context of change.